Okay, so we're going to try to develop a little bit more complicated form of the compound interest formula, one that will actually take into account different types of compounding other than just the once a year scenario. So let's kind of walk through what would happen if I want to compound quarterly for $1,000 at 8% a year. Okay, so quarterly simply means that every at 1/4 of the year, so 1/4 of the year would mean every 3 months, they're going to go into my account, look at how much I've got in there, and pay me 1/4 of the interest at that given moment. Okay, so kind of walk you through mathematically what it's saying. So at the end of the first quarter, so we're talking the end of the first 3 months, they're going to give me 1/4 of that overall interest. So 1/4 of 8% is 2%. So 2% of the 1,000, which is about $20. So the new balance is 1,000 plus 20, or 1,020. Okay. At the end of the second quarter, or now we're at the end of the first 6 months, they're going to give me 2% of that 1,020, which is 2040. And so I'm going to add those two amounts together. And now my balance is 1,040 and 40 cents. Okay, at the end of the third quarter, I get another 2% of that 8, but my balance is even bigger. So 2% of 1,040 is 2081. So I want to add that to the amount that I've accumulated thus far. So now I've got 1,061.21. And then the last quarter, so the last 3 months, this puts me at the end of the first year. I got 2% times the 1,061, which is 21.22. And I'm going to add that to the 1,061 for a grand total of 1,082.43. Okay, so I have $1,082.43 just sitting in my account, and I've made over $80 just letting it sit there. Okay, well, there's got to be an easier way to do that than have to literally go in there and multiply it by each time. And there is, and that brings up that formula that they are showing there. So A still stands for the starting amount or the balance A stands for the starting the balance at a given time. P stands for the starting amount or the principal. APR still stands for the annualized percentage rate. N is a new variable for us, and that's the number of times compounded. And then Y is still yearly. So just a couple of common ends that you might hear. If we say compound annually, that would mean N equals 1. That's the case we kind of started off with, so it's not that exciting. If they say compound quarterly, like we just did, that means they're going to go into our account 4 times a year. If they say compound semi-annually, that's twice. If they say monthly, that's 12 times. Daily, typically treat as 365. So you want to watch out for those key terms when you're working out various problems with this. All right, you deposit $5,000 in a bank account, which that pays an APR of 3% and compounds interest monthly. How much money will you have after 5 years? And compare this to the amount you'd have if interest were paid only once a year. In other words, compare it to compound monthly versus compound annually. What would be the difference in the amounts? Okay, so we're going to set up our formula here. Let's see, so we have the amount at the end of 5 years would be 5,000, 1 plus, and our APR, so it's 0.03 divided by 12, raised to the 12 times 5 power. And I'll kind of, let's see, I'll kind of use the calculator to help do that. I'm going to start with that 0.03 divided by 12, and I'm going to add that to 1. So that's 5,000 to the 1.0025 raised to the 12 times 5, which is 60 power. So if I raise this thing to the 60th, and then I multiply that by 5,000, I should get 5,808.08. Okay, now let's compare that to the once a year scenario. So 5,000, 1 plus 0.03, and we're just going to raise that to the 5th. So 1.03 to the 5th, and go to our calculator. So 1.03 to the 5th times the 5,000, and I get 5796.37. Okay, so clearly compounded monthly is a lot more desirable than compounded yearly, once a year. Okay. All right, annualized percentage yield, which is different. So the annualized percentage yield is also called the effective yield. Or sometimes we'll just shortcut it and say the yield. And this is the actual percentage by which the balance increases in a given year. Okay, in other words, whenever they say it's compounded monthly or daily or semi-annually, there is a simple interest that we could also compare this to. And that annual percentage yield, or APY, is that simple interest that translates to whatever interest they mentioned in the compound interest part. So a lot of times we want to compare the two ideas. So APR would equal APY when you're compounding annually. So when you just go in and look at it one time, you're going to see that your APY is the same as your APR. You get the same amount in that given time frame. For the most part, APY is going to be greater than APR as long as N is bigger than 1. So as long as they look at that account more often, even though they advertise a certain APR, you're going to make more money because you're adding interest to your interest, if that makes sense. Show how different compound periods affect the APY for an APR of 8%. Okay, so we're just going to kind of look at some different amounts and just kind of see if as we increase N what happens. So let's say we've got n equals 1. We're going to keep all the other parameters the same. So let me kind of remind us here. We've got a equals principal times 1 plus APR over n, and n times y. Okay, so we are saying, as we're looking at these different amounts, that if n equals 1, then our APY and APR would match. So we're not going to worry about a principal. We're just going to look at that 1 plus APR divided by n. So 1 plus 0.08 divided by 1 raised to the first power would actually still give us the 0.08. I'm sorry, would still give us the 8%. I feel like I should type this in. Okay, so 0.08 divided by 1 does nothing, and we add that to the 1, we still get 1.08. So if we raise that to the first, we still get 1.08. Okay, so how much did our 1.08? So we still increased our balance by 8%. Now, if I look at it, say, 4 times, that's 1 plus 0.08 divided by 4. And again, we're just saying in a year, so we're not looking at multiple years here. Clear that up. So 0.08 divided by 4, so plus 1. And then we want to raise that to the fourth power, and I get 1.824. Okay, so our balance has actually increased by 8.24%. Do a couple more here. So 1 plus 0.08 divided by 12 raised to the 12th. So 0.08 divided by 12. Now we're going to add that to 1, and we want to raise that to the 12th power. So I get 1.083. 8.3%. Oh, let's just look at one more. We'll go 365. So 1 plus 0.08 divided by 365 to the 365 power. All right, 0.08 divided by 365. We get that lovely number. I want to add to 1. Then I want to raise it to the 365th power. And I get 1.0833. So you're probably thinking, as we keep getting n bigger and bigger, is that will our percents increase? And the answer is, it's going to start to slow down after a while. It's about, we're about 8.33 is about, and keep in mind I did round that. So even as we increase that, we're not going to get too much higher than that.